Hi everyone, and welcome to Maintaining Maven at Scale. My name is Tim Beek, and I'm a staff software engineer at Moderne, where I work on the developer experience team developing both OpenRewrite and the Moderne CLI. Now what you're looking at here is my GitHub profile, and if you look closely, you'll notice that there's two things in there that I really like. In the top left corner, you can see that I really like to grow a beard while hiking in Patagonia, as you can see from my photo and my complete absence in November and December. The other thing I really like is contributing to open source software. As you can see on my frequent contributions, both throughout the week, but also on the evenings and weekends. In the past couple of years, these contributions have been on the theme of OpenRewrite. And now that I work at Moderne, I'm uniquely positioned to contribute to open source software at scale. That said, this is going to be a presentation where I will show you how I contribute to a 20-year-old application for fun. So if you're expecting some kind of flashy, slick presentation on this very nerdy, geeky topic, that is maybe on you, not on me. But I hope to bring you along to my idea of fun and hope that we will be able to find common ground. Now, to give you a very high overview of what I will tell you is that first I'll take you through why would anyone even contribute to open source software, because it's a valid question and maybe I want to dive in there a bit. Then I'll show you how I'm making my contributions and I'll show you what I've been doing for Apache Maven. I'll take you through a demo of developing these code changes and I'll show you a bit about what next and how you can get involved as well. Now, the first question is maybe why? There's a lot of folks spending a lot of time developing open source software, and it's definitely not for the feedback that you get in the bug and issue trackers. For me personally, it's about giving back. I've been using open source software my entire professional life, and what you might not realize is there's a lot that open source contributors do for you, and that you might not fully be aware of or even fully appreciate. In that sense, they're a bit like your parents. You only fully realize what they have been doing for you selflessly for years and years once you start to fill a similar role for someone else. And once you do realize, you start to want to give back and fill in that debt that you've been building up. So if you do see an open source maintainer out here in the hallway, go ahead and give them a hug, just as you would your parents as well. So one of the things that has drawn me to working on open source software is that you get to work with some of the smartest and kindest folks that I've ever had the pleasure of working with. That's maybe not the case if you read the Linux kernel mailing list, but especially in the Java ecosystem, I find that folks are very open and friendly to work with. And it is a small world. It's a great way to, if you contribute, to expand your network and find people that you might want to start working with more and more. It's also a great way to expand your technical skills, because every project works differently, and you might find that you learn some tools that will carry over into your day job as well. And it's a great way to grow your knowledge on a project that you might be aware of, but haven't really delved into the finer details yet. And you can also work on your soft skills, especially as if English isn't your first language, then working on open source software is a great way to expand your language skills and work on your skills of persuasion if you want to slightly bend the rules to get your ideas across. And for me personally, it's brought me to presenting. By contributing to open source software, I was able to get on stage here and share with all of you what I've been doing. And for me also, it's a moment of zen. It's a stress-free break from the regular work where there's no meetings, there's no planning sessions, there's no deadlines, unless you're giving a DevOps talk. And often I find that the work that you're doing is very appreciated. In my case, I feel very productive when I make these changes at scale. And in that way, I found that the entire Java ecosystem has been my Zen garden, where I go to clean up software to help with my OCD. It's also a great way to show off what you work with and how you work and the technical skills that you've adapted, where your GitHub profile becomes a public record of the work that you do. And I've been fortunate enough that I've been asked for every job I've ever held just based on the way that I've contributed to open source software. And I've never had to do a technical interview either, which is a great way to get in, because they could just see how I work. That doesn't mean that you don't get questioned about your skills. So when I joined as a consultant at a bank a couple of years ago, there was some slight hazing from an existing employee there, where he thought, well, you say you know Spring, we'll give you the hard job that we had over the past week. So here's a class, and we're having some issues with it. Could you have a look? And he was slightly abrasive about it, but we got behind his laptop, we looked over the class, and as we went over it, I thought, this looks familiar. And as we went through the code, I asked him, like, could you scroll up a bit? And sure enough, at the top of that class, there was my name. And that kind of brought him down a notch. I didn't have to prove myself anymore, and we could just focus on getting the job done. And that brings us to my work on Apache Maven. Having met some of the folks at conferences over the past couple of years, I've been looking for a way to give back. I'm sympathetic to the project, as I've been using it for 15 years by now, and I want to see them do well. Because especially in my line of work, if you're making contributions to hundreds of projects at a time, you probably want a build tool that is predictable and will look the same on every project. Now, if you're new to Java development, then Apache Maven is a project with a rich history to it. They've been going for some 20 years, and the development is spread across some 90 repositories. But there's no one big company behind it. Instead, it's all maintained by volunteers who choose to work on whatever feature they want to work on, and on their own time as well. So if you report a bug or an issue, you're going to ask someone to spend some of their evenings or weekends to really go over your issues, because that's the way it gets done. And that kind of history that they have also is starting to show in the code quality. If you go over the project, you will find that there's duplicated clauses, there's maybe some outdated dependencies, the code style might be something from a different era. And especially now, moving to the Apache Maven 4 release, which has been coming up for a while now, they're focusing firstly on faster builds and reproducible builds and the split in the build and consumer palm, which will have effects beyond the just Apache Maven, as it will affect all users of Maven Central as well. But the problems that they're facing in terms of the code quality are not unique to Apache Maven. If you look across the entire Java ecosystem, there's a lot of code quality issues that have built up over time, especially now that there's new versions of Java coming out every 6 months. And you only have to look at a change like Jakarta to know that there is a big backlog of technical debt that needs to be covered. And if you're asking volunteers to do that on a Friday evening, you're not going to get a lot of takers. So instead, we're going to look at how we can tackle some of these challenges through open source software. And for that, I'm going to use the combination of OpenRewrite, which is an open source framework for automated code changes, and the Moderne platform, which takes those automated code changes and runs them at scale. Now, if you don't know either of those, you're going to be in for a treat. We've just last week been featured in the ThoughtWorks Tech Radar, and it's just become a really great way to maintain projects that have a rich history to it, but with changes that you wouldn't want to be doing by hand, especially not on a Friday evening or on your weekend. Broadly speaking, the code changes you can make through OpenRewrite, you can be divided into 3 categories. Firstly, there's the any kind of security vulnerabilities that you might want to resolve by either updating dependencies, which is the very core basic thing, but you might also want to move away from insecure code patterns. If you have a vulnerable XML marshaller or you have something like zip-slip, you don't want to go and find those individually across the project. You just want to fix them at scale with these automations. Another category of fixes is static analysis findings. So if you have a tool like Sonar or Checkstyle or Spotbugs, those will give you findings and ask you to resolve those. But that's not a fun thing to do. Instead, what we've done with these open source recipes that are in large part also contributed by the community is just to apply the fixes immediately. You run a recipe, you get a fix, you create a PR, and you're done. You don't have to think about that anymore. And lastly, there's a whole category of upgrades that we can do. So if you want to move to a newer version of Java or a newer version of a certain library, then we can combine certain recipes together to get you to update, for instance, from Apache Client 4 to Apache Client 5. But we can also do that for Spring and Micronaut and Quarkus and all such frameworks. Now, I've told you that we can do code changes, but I want to highlight just one case to show you how that's actually done. And for that, we're going to look at a migration from JUnit 4 to my JUnit 5. You've probably done that in the past, where in JUnit 4, if you wanted to assert that a certain exception was thrown, you had to add that exception class to the annotation. But if you want to move to JUnit 5, they've instead moved that to a method, where you now take that same argument and you call that with a lambda to ensure that that exception is actually thrown. Now, on the face of it, this is not a complicated change. You can probably see how to go from one to the other, but if you have a couple thousand unit tests, you don't want to do that by hand. And it's also not exactly something that you can easily do with a regular expression, as you would maybe do for an import. Instead, you want to be absolutely certain that if you automate this code change, that you don't have to look at it again. And that's what we're able to do with these automated migration recipes. The way these recipes work is that we have plugins for Maven and for Gradle, open source, able to use that on your own machine, which will build up a model of your code. And maybe from your education days, you'll remember the concept of an abstract syntax tree, but we take that a step further by building up a lossless semantic tree. The differences there is that we add very deep type attribution, such that we can replace exact matches just based on the type rather than on whatever is only visible in the individual class. And we also add the surrounding code style, such that if we do insert new code snippets, that they will look exactly like the surrounding code style, rather than switching you from tabs to spaces and end up with a pull request that might not get accepted. Now, as I said, we're open source. We have a lot of recipes, and a lot of these are contributed by the wider community. We started out with great support in the Java ecosystem. As you can see in the top left corner, where you have support for Java and Groovy, Gradle, Maven, all of the familiar technologies that you probably use day to day. But especially for the frameworks, these recipes are often contributed by either members from the community or friends of ours who work at companies like VMware, Red Hat, Oracle, and they develop recipes for their own frameworks such that their users are able to migrate whenever a new version comes out. And we saw that recently with the new version of Micronaut, where on the day of their release, they were able to offer their users an automated migration, such that in a couple minutes, you're up and running with the new version, rather than have that be something that you might push off to a later date. Now, all these recipes you can implement in a variety of ways, and I'll show you a few in the demo. The simplest of this is just as a declarative recipe, which is nothing more than a YAML description file where you take an existing building block and you add some parameters to it. And this is perfect if all you have to do is, for instance, rename a method or rename a class or a package or swap some arguments. All these things that you've been reading in migration guides for years and years. But you're now able to automate that very quickly with just some lines of YAML. If you need slightly more, then we have a way to define refaster rules, which is an approach that we've copied from Google Error-Prone's refaster, where you provide just two annotated methods, one with a before template and one with an after template, and we will work out the details to convert your code from the input to the output and assert that it all stays working. Lastly, if you need more than that, you need a more complicated way of describing, maybe with some conditionals, what you want to achieve, then you have the full flexibility of the Java language available by implementing an imperative recipe. And I'll probably won't show you one in the demo, but know that you have that flexibility. You can have all the options of the Java language available to you. Now, as I showed you, we have some categories of issues, but we also have a large collection of existing recipes that you can immediately use. So if you look at, for instance, the top 10 of frequently occurring static code analysis issues, then we're able to resolve this just with existing recipes. And the same goes for those migrations that you might need to do, which I still hope to apply for Apache Maven, going from the HTTP client 4 to 5. But if you want to run these recipes, the way I do it is through the Moderne platform, which is a web interface that we have, which is free to use for open source software. All you need is a GitHub login, and you're able to start applying existing recipes to some 31,000 open source repositories. And I've been using Rewrite and Moderne a bit side by side, but I want to highlight the differences a bit because I find that it often pops up in the questions. So Rewrite is an open source framework for code migrations. You can use our plugins for Maven and Gradle to run those recipes on your own machine on an individual project. If you want to run those exact same recipes, but want to run them at scale, across not a single repository, but dozens or even hundreds or thousands, then we have the Moderne platform that allows you to do exactly that in just under a minute. So that then brings us to the work that I've been doing for Apache Maven. And that can broadly be defined by the same categories that you see, with quality improvements for the code base, making sure that it feels like it's running on the Java version that you expect, such that your IDE will show you less warnings. It's also adapting to breaking changes, and lastly, I'm also looking to help users adopt the latest versions of Apache Maven. Because if you've run the latest versions, you probably have seen some warnings that you're not defining a version for a certain plugin, or there's some other minor issues that are maybe easy to solve, but not something that you want to solve repeatedly. So what we're going to do is we're going to go to the Apache Maven Jira tracker. And we're browsing this one, I think, is fun. Because it's not just one project that they have in there. No, they have 72 different projects in Jira, each with their own backlog going back some 20 years. And it's not uncommon to find improvements that have been suggested in 2006 that are still waiting for a volunteer to pick up. So we'll take you through a demo, and I'll quickly sketch what I'm going to show you. Firstly, I'll give a brief intro to the Moderne platform. Then I'll show you how I'm actually finding things that I want to improve for Apache Maven. I'll run you through just one recipe development that I did for Apache Maven that is now also available to other users of OpenRewrite. I'll give a very brief overview how you can run this at scale with the Moderne CLI, which again is free to use for open source software. And I'll take you through a bit of the human side of it, because if you're making code changes, someone will get a notification and will be having to review that before it gets merged. And so we're gonna swap here. Let me check. And this then is the issue tracker for Apache Maven. I think with this screen we can zoom out a bit. What I've done here is I'm showing you just the 72 projects that they have. And these are plugins that you'll probably recognize. And what I'm going to do here is just open the one for Apache Maven. And then this one doesn't have 5 pages, but it has, I think, some 10 pages in total of 500 issues that if you want to find something that you want to contribute, you can probably find something on here. And these are just the issues that are still open. There's also a large collection of issues that have been resolved, but they've probably only been resolved for a single Apache Maven repository. So there's really a large collection of work to be done. So as a simplest example of the work I've been doing, it's this one, is replacing explicit types with the diamond operator. Now, if you've been using Java for a while, you probably know that in Java 7, they added the diamond operator, where you can use the square angled brackets to remove the explicit types if they can also be determined from the left-hand side. And this is something that is a very simple change to make. I'll show you just one diff where I ran this for the Doxia book renderer. you just should take the right-hand side and you make it into this. Fewer issues reported in your IDE, and the code will be slightly more readable. But it's not an exciting change. It's definitely not something that someone would willingly do on their free time. So instead, what I've done is I've automated the change, and taking you back, come on. I've run this repeatedly, so you can see that all these pull requests I've been able to automate and get accepted and merged so far already. So, and the way I run this is, again, through the Moderne platform. So I'm hoping the sign up works. All you need is a GitHub account and you can get started. So this is the Moderne platform. Again, free to use for open source software. And you can run some 1,280 recipes that we have against some 31,000 projects. And what I'm going to do here is I'm going to select Apache Maven, which is a collection of some 93 repositories that they have. And what I'm then going to do is I'm going to search for our recipe for the diamond operator. So we pick that one, and we just click dry run. Run it across 93 repositories. And ideally, if the Wi-Fi allows, you already see that the results are pretty much instantaneous. Something that you would otherwise have to do in your IDE, you can now see run across all of these projects. And if you look at the changes, you can see that it's exactly what you would expect. We replace the explicit types with the diamond operator. If you think this looks good and you want to do your first contribution, you can click on a button, and this will you can either commit directly. But I'm not a committer. I'm actually an open source contributor, so I have to go through a pull request. So we automated that for you as well. Just click this button and you can start a pull request. Now I recommend you only do this if you've had some contact with the project that you want to contribute to, because you only want to open this if it has a good chance of being accepted. But if the benefit of the platform, I think, is right here, you're seeing me contribute to a single project. But if you have gotten to know the folks a bit, you can also go back and select all of them and immediately commit all of this. And this is a way that I've been able to remove this diamond operator from a couple dozen projects already, in just under a couple minutes. But there's more improvements that we can make, and I'll take you to 2 more examples before we dive into the recipe development. There's another one here which is just about simplifying conditional expressions, and might sound a bit complicated, but I'll just open one example where, again, I've had this merged already, where you can see that we take a method which returns a Boolean, but it had a conditional at the very end of the method, where if the conditional was true, we actually return true, and if not, it returns false. But you probably know that you can also immediately return that whole expression. So what we've done is we have another recipe that actually achieves this as well. And that is this one. But if you run this on its own, it will not produce perfect code. If you have any kind of negations, it might look a bit odd when you end up with double negations. So what you probably want to be doing is combine this with another recipe. And that you can do with this one, which ensures that any of those double negations get cleaned up. And the way we do that is by combining them in a builder. So if we click here, we end up with a builder where you can run multiple recipes at the same time, such that the end result will look exactly like what you want. You don't have to write a complicated recipe that does all of this. You can just use these, combine these existing recipes to get the result that you really want. And again, you can run all of this, and it will start to show you exactly what you want. And the end result is that the code will be improved with a number of these changes applied at the same time. Now, you've already seen me do a diff and how you can actually commit this. So instead, what we're going to do is we're going to look at the bulk of the work that I've been doing for Apache Maven. And when I told you that they have a rich history with some duplicated classes, this is what I meant. Large part of the issues that they were having that no one in their right mind was going to pick up on their off time is duplicated classes involving string utilities. What I did is I looked what they had, and they had some 4 different string utilities clauses from 4 different dependencies for a total of a number of megabytes, all of them mostly to check if a string is empty or if a string is not empty. You don't really need a dependency for that. You certainly don't need 4 dependencies for that. So what we're going to do is we're going to find these instances and we're going to clean them up. And the way I find those is, again, with another recipe. So what I'm going to do here is I'm going to find how big the problem actually is still at Apache Maven. And for that, we run a find, and we're going to look for any string utilities class from any dependencies, any method on that with any number of arguments. And if we run this again, I guess some 93 repositories will quickly see some results. And I'm not really interested in the individual results. Instead, what I'm interested in is a data table of what we've actually found. For that, I have to wait for the full run to complete, which typically is just a couple seconds more. And then what we get out is an Excel sheet. And that Excel sheet will help us say, well, you're using an isEmpty call here, you may be using a repeat there, you might be using a few more. But what the end result is that you're able to really prioritize the work that you're doing by saying, well, if I want to go replace something, then this is the best bet. And when I started out, they had some 12,000 instances of 1,200 instances of checking if that string was empty or not. And it's just not something you're going to do. You're not going to do that by yourself. I'm not getting the table to load in the time that I want, so I'm going to skip this. Or is it? No. Oh well. So coming back to the presentation, I'm going to show you how we actually write a recipe to do these replacements. And for that, we're going to look at the refaster style of recipes that I showed you. But the first thing I do when I develop any new recipe is I start with a unit test. It's just a good way to be sure that whatever I'm going to write will end up with the code result that I want. And for that, we have some structure where we just say, well, extend this one interface, run this new recipe of ours, and with that setup, we can actually start to assert that the code changes that I'm going to make are going to replace the top snippet that you see here with the after snippet that you see right below. And what you see me do here is an intentionally very naive implementation of this test. And we're going to write a recipe that actually achieves exactly this. And that's this class. So as I told you, you get 2 methods. You annotate them with a before template and an after template, and we will work out the details for you. But this is a bit too naive. I can also write a second test, which will actually fail, and that's this one. Because the string utilities class actually checks for nulls as well. Or I should say, 3 of the 4 string utility classes check for null or not, so we need to be a bit more specific when we do these replacements. So instead, we need to replace it with an expression, which first checks for null, and then checks if the string is empty or not, such we don't end up with a null pointer exception. And we can do that in our recipe as well. So we slightly change the after template by now adding that null check in front of it. But I can think of another test which I can fill here, and that's if you introduce negation. So if you put an exclamation mark before this method, which you shouldn't do because there's also a string utility is not empty, but if you go through that data table, you'll get humbled and you'll see any kind of patterns which are not ideal, but you want to move away from. So what we need to do is we need to add these parentheses such that that exclamation mark actually ends up negating the entire expression that we insert. So we go back to our recipe, we add the parentheses around it, and we're getting near a complete recipe. But if you then have this, you probably know that so far you've only seen me in my test use simple variables going into the before and after templates. But you can also, in the actual code, see instances where they, for instance, call a getter method. And you don't want to not replace these instances, you want to replace those as well. So we have to, you can use the exact same recipe, But be sure to also do these replacements, because it doesn't make sense to keep these dependencies around for such cases. But what you don't want to be doing is you don't want to match on any kind of things, method calls which are not a simple getter. So if it has any arguments or it doesn't start with get, you might not want to do that method call twice. First to check if it's null, and another time to check if it is empty or not. So what we've done here is we're limiting the arguments going into the before plan template with the repeatable argument matcher, which is just something that checks, well, if it's a primitive, it's probably fine. If it's a getter, it's probably fine. Anything other than that, and we're not going to match. We're not going to apply this recipe. And what we can do to verify this is the last unit test I'll show you, where we only have a before situation, but we still run the recipe. And what we assert is that this one is not changed. This one will stay exactly the same, so we're able to assert this as well. And so with that, we're done with this one replacement. We have a recipe that works, it's a couple lines, and we want to start running this. And the way I run it typically when it's a new one is I run it on my own machine. And for that, I use the Moderne CLI, which makes it possible to not run it just against a single project, but across a couple hundred even, if you want to be sure that it actually works. And you can verify that by running just a Maven build right after. And for that, we have developed this CLI, and we made it very familiar for users of Git. You'll see some commands that you probably recognize to clone repositories, or to create commits from the changes that you've made. But we're also able to run the recipes, and for that, you can see me here run this diamond operator recipe against just the 93 repositories of Apache Maven in a couple minutes and verify that it all works, such that if I start making pull requests, that it will actually work. But when I do create a pull request, that ends up on the mailing list, and you don't want to send out something that you're not sure will work, because you might get some pushback if you start making changes, especially when you start making changes at scale. And one of the issues I came across just last month is that I was breaking the rules a bit for Apache Maven. Because if you read their contribution guidelines, there's one thing that they ask you to do, and that's illustrated by this conversation that we had on an issue recently. So my change was all well and good. It actually worked, it was already approved, it was getting ready to get merged, but then Olivier chimed in with some valid criticism. And his criticism was that there's a convention. If you do any contributions to Apache Maven, you should be using a tag specific to the project that you're contributing to. Those 72 projects I showed you on the Apache Maven Jira board, they all have their own code, and they expect you to use that code when you create an issue and then create the fix. But you could see that I can do these contributions in a couple minutes. But I don't quite can automate that, making those Jira tickets, and I actually don't really want to. I'm a bit of a nerd, but I don't want to spend my weekend writing Jira tickets. I do this work to get away from that. But luckily, Sylvester agreed. So we've had some prior discussions about this, and he said, well, we agreed that it's not really feasible to make a Jira ticket for any of these improvements. But Olivier wasn't convinced yet. He said, well, where's this agreement? We have a mailing list, I didn't see it mentioned that, and we'd only informally discussed this on prior pull requests. But I was really getting worried. I was having a lot of fun creating this pull request, and I did not want to start making Jira tickets, so I went maybe a bit overboard. I put my language and persuasion skills to the max to really convince them that maybe it would be better not to have individual tickets if all they do is refer to an existing one. And luckily, in the end, because you don't want to make these tickets, because I've done the math before. If you take the 93 repositories that they have, and the some 20 recipes that I want to run, and the 72 projects that they have at Jira, and then knowing that I would probably have to do repeated runs for a number of these recipes, you quite quickly end up with hundreds, if not thousands, of Jira tickets. And luckily, That kind of convinced Olivier that, okay, it's good to proceed, provided that you only do small incremental improvements of a single recipe, which is easy to review, and you refer to a single ticket. And luckily as well, Elliot agreed with me, and he said, well, if you have any of those pull requests, just send them my way, and he'll see them through. And I was quite pleased with that. I no longer was fearing that I had to do the Jira issues, and I could actually focus on what's next and keep contributing. And so with that, I'm starting to make more and more of these changes, but we'll look briefly at what's next and how you can get involved as well. Well, one of the things I really like is that as part of this work, I'm doing improvements which will flow back to users of Apache Maven. Now, as I told you, if you're using recent versions, you're probably seeing some of these issues called out as warnings on the command line. And anytime you see a warning, it's an error in the making. So you probably want to resolve this now rather than find them when you go to a new version. So on the left, these prefixless expressions, you probably want to do replacements, but you don't want to find those by hand. Just run a recipe and you should be able to fix those immediately. The same goes for the missing plugin versions. If you run a plugin and you're not explicit about the version, you have a build that's not reproducible. That's not ideal because it might work today, but it might break in 2 months if there's a new version of the plugin available. So we're going to pin you to the recent version of the plugin, and that way you're able to be sure that your project will build in time as well. And we're also looking at dependency relocation, where there's a new version of a dependency that you might not be aware of because the group and artifact ID have changed. And we're looking for ways to get you on the new relocated dependency just with another simple recipe run. But what I really like about this type of work is that it's easily scalable to not just Maven, but a lot of other projects in the Java ecosystem as well. I've been doing these commits not just with Maven, but also with Spring, with Micronaut, Axon, and all of the technologies that you see here. So if you maybe want to get involved, you can look at some of those projects as well. And what I really like about this, it is not just me doing these code changes. We have friends of the project who are using this for their own use cases as well. So we have Steve Hill on the left, who is using these exact same tools and applying those to some 300 Jenkins plugins that he's maintaining, which he needs at his job. Because if those plugins are unmaintained, he has work to do to actually adopt to something new. And he'd much rather run an automated migration to keep those plugins maintained. On the right-hand side, we have Jonathan Lightshoe, who is a security researcher who is making automated fixes for security issues across the Java ecosystem. He does repeated runs fixing zip slip or vulnerable XML transformers, and he runs them across those 31,000 projects we support on a weekly basis to make sure that the entire ecosystem is safer for it. Now, if you want to get started, because you can see it's quite easy to do, then what I recommend is that you find something that you're passionate about. For me, that's Apache Maven, but it might be something similar for you as well. You'll want to find a project which has some activity to it, because if you're making a pull request, you don't want to be adding to a stack of some 200 open pull requests, because it is unlikely to get merged. You'll also want to find something that matches your skill set. So while I'm sympathetic to the OpenJDK project as well, I don't feel I have the necessary skills to do any kind of valuable contributions there. You'll also want to be sure to follow the guidelines. You could see me skirt the rules a bit with those Jira ticket issues, but if you want to be sure that your changes are accepted, go have a look at what's actually needed to get your changes through. Maybe start by introducing yourself and proposing your change rather than spending a lot of effort in creating a pull request that might not be acceptable. I also recommend that you start small with maybe some clear improvements, such as that diamond operator, or bringing their test suites from JUnit 4 to JUnit 5. These are unpopular but valuable fixes, and you can use them to gather feedback if those changes are actually desirable or not. And from there, you can propose a next step and maybe find the next thing to work on and really grow both your knowledge of the project and the types of contributions that you're going to be doing. And then you probably want to have patience. Especially in larger projects, it helps to find maybe an ally that will help see your pull request through and maybe spread your chances a bit, because oftentimes you're asking folks to review something on their evening or their weekend, and it might take a while before you can see your work come through. Now, if you want to read a nice blog, which was released just last week, and there's this one about how to be a good open source contributor, especially with Hacktoberfest, which usually sees a flurry of open source contributions. And be sure that the work that you're doing is actually proving valuable rather than adding noise. And that said, this brings us to a small section where I want to just say my thanks to a number of folks that have helped me as I'm making these contributions to Apache Maven. The two on the left have been instrumental in seeing my pull requests through and helping push back whenever I got some criticism from other contributors. The two on the right have been engaging me and helping me motivate me that these changes are actually worth doing and that I should continue down this path and maybe what to look at further to do next. Now, if you want to get involved, then I recommend these 3 resources. The top one is the guidelines for new developers to Apache Maven, where you can read all the things you have to do and abide by to get your changes through. The middle one is the OpenRewrite, the open source technology that you can use on your own machine to run these exact fixes to maybe modernize your own projects as well. And finally, there's the app.moderne.io, which is the web interface, which I showed you, where you can download the CLI and you can use that to modernize the open source projects that we already support. And with that, I would like to thank you all for your attention. Now, this has been a new talk, so I'd appreciate any kind of honest and constructive feedback. So if you have anything to share, then open up the progressive web app that they have for DevOps, and please let me know if there's anything I can do to improve this talk still. And if you want, I have some stickers, and we're also hiring, so if any of that is interesting to you, then feel free to come up as well. I see we have some minutes left for questions, so if anyone has any, then just raise your hand. Yeah, I'm not sure if you have a microphone. Oh, yeah, sure. I'll repeat the question. Mm-hmm. So your question is, you saw me combine certain existing recipes, and the question then is if users can contribute that particular combination of those recipes to achieve the end result that you want. It's a good question. You saw me in that builder build up a collection of recipes. You can also contribute that collection as something that you apply a single label to. So if you want to have a grouping of Boolean improvement recipes, then you can do that and make sure that they run in a particular order to get that improvement that you're looking for. So that is definitely something you can contribute. We don't see that often because we usually combine it into larger and larger groupings, but it's definitely something that you are able to contribute. Yes, sure. Cheers, thanks. Yes? So the question is, how many lines in code did I change in total? I've done, I think, over 100 pull requests by now. Typically, I only do commits when they run against at least 10 files. And yeah, that kind of starts multiplying into thousands by now. I didn't put any stats in there, I probably should have. But it's very much an ongoing process. So some of these pull requests, they're still open. Some of them I opened just last week. I've actually been ruining my demo as I just found things that I could immediately fix, but then I couldn't show you anymore because it was already fixed. So it's really fun to work through. but it's very much ongoing. So yeah, thousands of lines, but continuing on. So cheers. Anything else? Yeah.
Is it possible to do multi-file refactoring? So when you take source from one file and actually move it to another file while doing refactoring in process?
So the question is it able to do multi-file refactoring, where you take part of one file and move it into a new file?
Yeah, for example.
Yep, that is possible. If you, we have different forms of recipes, so you probably need an imperative recipe, which is a dedicated Java application, which you can unit test as well. And what we have there is the concept of a scanning recipe, which is more advanced within the imperative recipes, which is able to do initial pass over all your source files, build up whatever collection of files that you then want to transform, and use the information that you gather there to make the code changes in a second step. So that is possible. It's more advanced. I'm not sure if it's something that you would apply repeatedly, but knowing you and the projects you work on, you probably have some use cases for that. So do reach out if you want to look into that. Cheers. I see the questions dying down a bit, so feel free to come up if you have any more, and then I'll make room for the next speaker. So thank you all.